In Millikan oil drop experiment, an oil drop carrying a charge Q is held stationary by a potential difference of 2400 volt between the plates. To keep a drop of half the radius stationary, the potential difference had to be made 600. What is the charge on the second drop? So there are two things are compared. First one, there is a potential difference of 2400 volt. There is a oil drop having charge Q held stationary. Let the radius of this is R1. Second case, the radius becomes half. Now the radius is R2, where R2 is equal to R1 by 2, half. Now the charge on this is a question where if you want to hold stationary between the two plates, the potential should be equivalent to 600 volt. So question is asked, what is that value of Q? Q is a question there. Charge on the second drop is a question. We know when we held this drop between the two plates, two forces available. One is a electrostatic force which is upward, and other one is a weight of this drop downwards. Both the cases F and W should be matched or equal. What is F? F is equal to, it is a Q into E, where E is a charge, E is a electric field. Electric field can be written in terms of potential difference. It is a Q, it's a V by D. D is a separation between the two plates. And W is mg, where m is a mass of the drop. I'll take the first drop as m1. So m1g. Whereas second case, same example, it is new force F2 and new weight, that is a W2. So therefore, here W2 is m2 into g, F2 is equal to, it's a Q and potential difference divided by distance. Now the parameter which changes here are, one is first case the potential is V1, let me write. Separation is same. Charge is not a small q, it's a capital Q. Therefore you can rewrite Q V1 divided by D is equal to M1 into G. It is for the first case. For the second case, if I write, it's a Q potential V2 divided by D is equal to M2 into G. Now what is the comparison of M1 and M2? M1 is a mass of the sphere of the drop which is having radius R1. If I say the density of that drop is rho, density of oil is rho, then M1 can be written as, it is volume 4 by 3 pi R1 cube into density. Second case M2, therefore is a 4 by 3 pi, it is R2 cube, R2 is equal to R1 by 2, R1 by 2 cube into rho. Therefore, if I find the ratio M1 by M2 is equal to, its rest everything is common, it is 1 by 2 cube. 1 by 2 cube means it is 8. 8 goes to numerator. Therefore, ratio is 8. Now, we'll use this in the simplification. We'll divide this. It's a Q into V1 divided by Q into V2 is equal to M1 by M2. And M1 by M2 is equal to 8. We'll rewrite, therefore, it is a Q into V1 2400 divided by Q into 600 is equal to M1 by M2 is equal to 8. We'll substitute as 8. Therefore, Q divided by small q is equal to 8 divided by 2400 divided by 600, 24 by 6, it's a 4. 4 goes to denominator. And 8 by 4 is 2. Hence, we got a value of Q by small q is equal to 2. Therefore, small q is equal to capital Q divided by 2. So, charge should reduce to half the initial so that we can hold that between the two plates.